Hello my dear students. So today we will be discussing electrochemistry and numericals related to Nernst equation. See, in the last classes we have discussed Faraday's laws and the next Nernst equation, right? So we will be looking into the questions of that concepts. We already discussed few questions related to those topics like qualitative aspect and quantitative aspect of electrolysis. Right now, so what is the product formed at the particular electrode? So that will be considered as qualitative aspect of electrolysis. Then next we discussed about Faraday's first law and second law, right? So this gives amount of particular product formed at particular electrode. So this is what quantitative analysis, like quantitative aspect, like how much quantity of product is produced at particular or amount of particular electrolyte deposited at particular electrode. This will be what? A quantitative aspect of electrolysis. Okay, then after that we discussed about this Nernst equation, right? So we will be looking into few questions of this Nernst equation and Faraday's laws. Okay, so look into it. So here we have a question from JEE Mains 2021. The question says the quantity of electricity of Faraday needed to reduce 1 mole of dichromate like Cr2O7 2 - 2 chromate like +3 ion, chromium +3 ion. So they are saying Cr2O7 is given -2. Okay, this will be converting into Cr +3. Okay, so what is this process? This is reduction, right? Yeah, so what they are saying, 1 mole of this dichromate has to undergo reduction like this. Okay, so reduction happens at cathode. This is the extra information I am just writing here. Okay, at cathode these things takes place, right? So now how much quantity of this how much quantity of electricity is required to deposit this chromium ion from this 1 mole of dichromate? Okay, so for this just count number of electrons change here. What is the oxidation state of chromium here? It is +6. How can you find that? For chromium you can say 2 chromiums are there, 2x. Okay, +7 oxygen, 7 into -2 for each oxygen, overall charge is -2. Take it like this. So your x value will be 6, +6. So +6 is converting into +3, right? So electrons gained is 3 for each chromium. We have 2 chromium atoms, so 3 into 2 will be gives 6. So total electrons changed, total electron gained in this process for 1 mole of dichromate is how many? 6, right? So 6 electrons are required. So for 1 mole of dichromate, so I am writing here, see 1 mole of dichromate, so how many electrons? 6 electrons in order to deposit this chromium ion from 1 mole of Cr2O7. So for 1 mole we required 6 moles of electrons. We know charge of 1 electron is how much? Charge of 1 electron is 1 Faraday. So it means 6 electrons, 6 moles of electrons are required. So 6 Faraday is required for 1 mole. So what is your answer for this? 6 Faradays are required. The quantity of electricity of Faradays. So how many Faradays? 6 Faradays. Since if it is like NEET question, you need to give the answer, right? So here you can type 6 as your answer. Hope this is clear now. Yes, if any confusion you can ask me. Okay, so let's look into the other question. Okay, similar kind of question. See, just count number of electrons required. So that many Faradays are required. That much quantity of current is required. So just to take here number of electrons required for deposition of a particular substance. So that many Faradays are required. So for 1 mole of Faraday, like 1 mole of electron, 1 Faraday is a charge. Okay, so for n electrons, n moles of electron, n Faradays. That's it. So you just take that integer value as your answer. Right now, next let us move here. Yeah, the amount of charge in Faraday required to obtain 1 mole of iron from this mixed oxide of iron. So iron oxide is given. So Fe3O4 is given. So you can write this Fe3O4 as 2 types. It's a mixed oxide, contains FeO and Fe2O3. These are the 2 oxides present in it. Okay, what is the oxidation state of iron here? It is +2. And what about this iron? It is +3. Okay, 2 irons with +3. So what they are saying, the amount of charge in Faradays, similar kind of questions, required to obtain 1 mole of iron. See, from this iron oxide, we should get 1 mole of Fe. So for this purpose, how much Faradays are required, they are saying. See, here when we are taking Fe +2 to Fe, okay, for 1 mole, see, 1 iron oxide like Fe2O is FeO is there. So for this we require 2 electrons. It means 2 moles of electrons, so that I can say 2 Faradays are required in order to deposit 1 iron from this Fe +2. Similarly from here, +3 ions are there. How many are there? 2 are there now. So 2 Fe +3 are there. So for this, so for 1 iron, 3 electrons from +3 to 0. So 2 are there now. So 3 into 2. Okay. So totally 6 electrons are required. So 6 electrons are required for deposition of 2 irons from here. So 6 electrons. It means 6 electrons means I can say 6 Faradays, right? So totally how many Faradays we are taking? Here 2, here 2. So 8 Faradays we are taking here in order to deposit here 1 mole, there 2 moles. Total 3 moles of iron. Hope it is also clear up to here. They are saying they just want 1 mole deposition of this iron. So for 1 mole deposition, what you need to do? So just divide this by 3. See, just divide it here by 3, here by 3. So for 1 mole of iron, you required how many Faradays? 8 by 3 Faradays are required. That's it. So this is your answer. So 8 by 3 means how much you will get? So it will be 2 point, okay, 2 3 is 6. So 2 is remaining, point means 0. So you will get 2.66 like that, 2.667 like that. This will be your answer. This many number of Faradays you require. Hope it is also clear now, right? Okay. So if they ask for nearest integer, go with the nearest integer of this number. That's it. That will be your answer. Hope it is clear. Yes. If it is clear, just tell me clear in the chat box. Yeah. Let's move further. Yeah. Now we will be looking into some other questions here. So based on this, you tell me if answer for this. I have KMnO4. Okay. They will be giving like this, either KMnO4 or they just give permanganate ion like this. Okay. By giving 1 mole of permanganate ion. Okay. So how many Faradays are required to deposit Mn+2 from 1 mole of permanganate ion in acidic medium, they will say, or they just mention it like this. So how many Faradays of charge or quantity of electricity is required to deposit Mn+2 from 1 mole of permanganate ion? Okay, they may give for 1 mole or they may ask it for 0.5 moles of permanganate ion. They want to deposit Mn+2. So how many Faradays are required for this purpose, for this process? By giving 0.5 mole. So I want answer for these 2 questions in the comment box based on your understanding of last 2 questions. Okay, very easy and you can do it, I know. Okay, so let's do few other questions too. Yeah, so here I have a question for you. See, look into this. This is from what? This is from Nernst equation. The question says, for the galvanic cell, Zn solid reacting with copper +2 with this much concentration of copper +2 forming Zn+2 of concentration this much and copper solid. Okay, this is a redox reaction, spontaneous redox reaction is given. So for this, what is the EMF generated? E cell, electrode cell potential of this particular cell, they are asking. So E cell equals to E naught cell minus, what is the Nernst equation we discussed in the last class? E cell equals to E naught cell minus 0.059 by N log concentration of products by reactants. What are the products formed here? So this is a product now. So concentration of product is Zn+2 you can write. Okay, and solid copper is there. So its activity is how much? 0. Okay, or its concentration is taken as 1, not 0. You should take it as 1. Okay, so its activity is 1 for solid substances. So here also for zinc solid, so it is also 1. Okay, so now product concentration by what is the reactants, here we have Zn, zinc, which is in solid, so its activity or concentration is considered as 1, and we have copper plus 2, its concentration you have to take, so Cu plus 2 concentration, like this. Hope up to here it is clear. Now what you need to make, so you can write here E cell equals to E naught cell. So what is the E naught cell for this particular cell? So E naught cell equals to, so we have two electrodes, one is copper, another one is zinc electrodes. So you need to understand what happening at copper, and see zinc is converting zinc oxide now, zinc plus 2 oxidation is taking place now. So oxidation potential of this zinc you should take Zn to Zn plus 2, like this. Okay, plus, and copper is undergoing reduction, so add reduction potential of copper, copper plus 2 converting into copper. Okay, so I am writing E naught of Cu plus 2 to Cu, like this. This is the standard way of taking. Okay, so in terms of reduction potential you should get like cathode minus anode, but I am not considering, I am taking like in a standard way only, as we have values here. Okay, so now what is the oxidation potential of this zinc mentioned? See, Zn converting into Zn plus 2, so take here 0.76 volt plus. Okay, and what about the copper plus 2 to copper, that is reduction, but here they mentioned oxidation potential, right? So oxidation potential and reduction potential values will be same, but with opposite sign. Okay, they mention oxidation potential, but here we should take reduction, because in the given reaction copper is undergoing reduction, so take here plus 0.34 volt, as they mentioned minus 0.34 as their oxidation potential of copper. Okay, hope it is clear. Now how much you will get from here? 4 plus 6, I mean here 0. Okay, so 1 means you will get 1.10 volt. Okay, so this is the standard reduction potential of this cell. We required reduction potential, we got standard potential, take here 1.1. Okay, minus 0.059, so consider it as 0.06. How many electrons here changing here? It is losing 2 electrons and copper gaining 2 electrons, so n value here it is 2. Okay, if they are different numbers, losing 2 gaining 3 electrons means just multiply them and you will get n value as 6. Here same number of electrons, take that number here. Okay, so in a reduction reaction always number of gained electrons and lost electrons should be equal. Okay, yeah. So the next, log concentration of Zn plus 2. How much Zn plus 2? 4 into 10 power minus 2 I can write. Okay, and copper plus 2, 2 into 10 power minus 2 we can write. Okay, so remove these two numbers and this will be gives you log 2, so you can say 0.3010, I am taking 0.3, and here you have 0.03 by cancelling out this. Okay, and here 1.1, so this is E cell value. Okay, so 1.1 minus this will be how much? 0.009, right? Yeah, so from this what you will get? See, so you will get the answer here as 1.09, almost like this. Okay, so this is the cell potential for this particular cell. Okay, so you can look, you have to express it in terms of something value into 10 power minus 2. So just you can write it as 109 into 10 power minus 2. So what is your answer here for this? 109 is your answer. Yes, yeah. Hello dear in the comment box. Yes, I am looking into it. You can express your concerns. I mean any doubt you have, you can just write here. I will express that. I will explain that. Yeah. So this will be the answer for E cell. Yeah. Hope it is clear. The next we will move further. Yeah. So just look into it. Any doubts or any way, any concern, just write in the chat box. Yeah. So the next question here we have. See, I just wanted to mention one more similar kind of question. Yeah, so yesterday's class I have explained this, so just give a try for finding E cell. Use the same method whatever I have explained, find E cell using the Nernst equation and you will get some answer. If you are facing difficulty to get the answer, just watch yesterday's live session, you will get the answer for that. It will be there in that. I have explained it. Okay, so now, yeah, so look into this. So if E naught cell for a given reaction has negative value, so what they are saying, E naught cell is negative. So is negative means I can also indicate this as E naught cell is less than 0. Okay, less than 0. Now for a given cell has negative value, write it. Which of the following gives the correct relation for the values of delta G naught and K equilibrium constant. So delta G naught, what is the relation between delta G naught and E naught cell? Delta G naught equals to minus NF E naught cell, right? So standard Gibbs free energy equals to charge into potential in the standard potential E naught cell. Okay, so now this is a charge. Since it is negative, since E naught cell is negative, already we have negative sign here, negative, so delta G naught will be equals to negative into negative, it will becomes positive. So delta G naught will be what? It is a positive value here. Okay, so like this you need to get the answer. So delta G naught will be what? Positive value or greater than 0 you can write. Hope it is also clear. Now what is the relation between delta G naught and equilibrium constant, K equilibrium? So we have delta G naught equals to minus RT ln K. Ln K is nothing but K equilibrium, right? So delta G having negative sign with equilibrium, right? So if delta G is positive, delta G naught is positive, K equilibrium will be negative. Since delta G is what they mentioned here, it is greater than 0, it means K equilibrium should definitely less than 0 you can write. Okay, so based on this understanding, look into the option which will be the correct one. See, same question were appeared in 2 times, 2011 and 2016. Okay, so now tell me which is perfect answer for this. Delta G should be positive and K should be negative. So here. So first option will be the answer for this particular question, right? Hope it is clear. Yeah, if it is clear, just tell me clear in the chat box. Yeah, let's move further. Again, based on the same explanation, you can give a try for this question. Again, this question I discussed in the last class, I mean yesterday's session of this electrochemistry, same time 6:30 class. Okay, so you can just check the answer once after you are solving it. Okay, so just look into it and check your answer in the yesterday's session. Okay, both sessions are very helpful. Whatever I have did on electrochemistry part, those are very helpful. I have covered all the important topics that must be studied by every aspirant of JEE and NEET and EAP set also. Okay, here I also wanted to tell you about our new batch announcement, that is what NEET 2026 long term program, which we are going to start from this July 1st, it means by today. Okay, so we are about to launch this program and we have launched it. Okay, and if you are seriously preparing for JEE and NEET exam, NEET 2026, you are happily welcome here. Okay, so you can join our sessions, I mean our batches, either live from your home or you can come to the offline branch, okay, in Narayanguda, Hyderabad. So both facilities are available and you can also have hostel facilities for offline students. Okay, and you will be having recorded lectures available in our app, Med World app. So you can access all your recorded lectures after completing those sessions. Okay, you can watch n number of times. Okay, so this is about the batch, and if you wanted to know more detailed information about the batches, just contact to the mobile number which is given in the description box. Okay, or you can access to the mobile number whatever they mentioned on the screen and also in the description box. Okay, the next thing is, this is about NEET, and here we are also launching for JEE. So batch fees is very affordable, that is 3333. Okay, so this is very affordable per month right now. So you can, if you are really interested, you can contact to the mobile numbers provided in the description box. Okay, next we will be solving few more questions. Yeah, so look into this. So calculate the standard potential of the cell in the given following reaction. So how do you do this? See, Fe plus 2 is converting into Fe plus 3. Fe plus 2 is converting into Fe plus 3, okay, and Ag plus is converting into Ag. See, given that they have given for Ag plus 2 to Ag, they have mentioned it as x volt. They directly mentioned for Ag, but they haven't mentioned it for Fe plus 2 to Fe plus 3. Okay, so but they given the data of other things. See, iron converting into iron plus 2, iron plus 2 to iron plus 3, like this they have mentioned. Okay, so for iron plus 3 to plus 2, so from here to here they mentioned as x. So now here it is from here to here you can consider minus x. Okay, oxidation potential I am writing. Okay, so next for plus 2 to plus 3, from here to here, from plus 2 to plus 0 they mentioned as a reduction potential as y. I am taking this is also minus y as oxidation potential. Okay, and in the reaction we required this. What is this oxidation potential? Okay, so let us indicate this value with some other number. See, they represented this as z, this as x. Now let us represent this number with something like p. Okay, what is this p we required now? So p I can write, see, for this, for Fe plus 2, Fe to Fe plus 3, I can write, so Fe to Fe plus 2 plus Fe plus 2 to Fe plus 3. Like this we can write now in two steps from here to here. It means step 3 equals to 1 plus 2 I am writing. Okay, that is what. So step 3 equals to 1 plus 2 I am writing. So here for step 3 how much it is? Minus z. So for step 3 I am taking minus z. So for step 1 here it is how much? Minus y. And here we need to get this Fe plus 2 to Fe plus 3 value. So how much it is? Fe plus 3 to plus 2 to Fe plus 3 will be how much? So minus z plus y. If it comes this side, it will becomes plus y. So y minus z is our answer for here. Okay, so you can mention this oxidation potential as how much now? Y minus z. Okay, this is the value we got. So we have everything now. So E naught cell is how much now? E naught cell equals to, see, during this process 1 electron, here also 1 electron. So there is no issue with the electrons. Okay, directly you can substitute here. So E naught of silver is undergoing reduction. Okay, reduction, and iron is undergoing oxidation. So Fe plus 2 to Fe plus 3, like this. Okay, so write the values here whatever they mentioned. For silver they have mentioned reduction potential value as x. So mention x, plus for iron oxidation potential value how much we got? Y minus z. So y minus z. So how many electrons here we are seeing? See, in this case we are seeing 2 electrons now. So that's why it should be 2 here. So here it should be 2. So here also it should be 2. So what is our answer? X plus, and for this one how many electrons it is? 3z now. So 3 electrons, 0, 2 plus 3. So here you should take 3. Okay, so 2y plus 3z. So look into the option which is of this type. So x plus 2y plus 3z. Okay, that is your answer. So where do we have like that? See, option 3 will be your answer based on this relation. Okay, so now this is the relation how you will get. So delta Z naught, this is the formula you have to use, because E naught cell is not additive. It is not additive. So what do we mean by additive? So delta G is additive. I will explain what is this additive concept. See, I told you that 3 equals to 1 plus 2 I told you now. So you should not directly take E naught cell of 3 equals to E naught cell of 1 plus E naught cell of 2. Okay, here you should take delta G3. So delta naught of 3 equals to delta naught of 1 plus delta naught of 2 you should take. Okay, so what is the delta naught of 1 means? So delta G naught equals to NF E naught cell. This will be the value now. So N means number of electrons. Number of electrons in one process is how many? 2, right? So 0 to 2 means 2 electrons lost here. So your N value will be 2. So that's why we got 2 into E naught cell value is Y. So 2 into Y. That's why I have taken here minus 2Y, here minus 2Y, and in this case 0 to 3. 3 electrons are changed. So that's why I have taken 3 into Z. Like that we have to take and we'll get answer like this. Okay. So now similar type of question I will be asking you one more. Yeah. So whatever the relation I told you for delta G naught. So delta G naught equals to minus NF E naught cell. This is a relation I given now. So based on this, so try to solve this. You will get one of these options. Okay. And if you are unable to get the answer, just go through the yesterday's live session where I have discussed this question. Very clearly I have mentioned, I have discussed everything regarding this. So just try this first on your own, go to that live session if you are unable to do. So just use this formula, you will get the answer. Okay. Next. Yeah. So those who are watching today itself as a fresh, just try to solve these questions based on what? Based on Nernst equation and Faraday's laws. So if you get the answer, that is good. If not, just go through the yesterday's session. So this also I explained in the yesterday's session. Okay. So take the screenshot of these questions and give a try. I hope you will definitely get the answer. If not, don't worry, just go to the yesterday's live session. Okay. Check these questions. Yeah. All these are discussed yesterday. Yeah. So this is about this session. Okay. So in the next session, we'll be discussing about concentration cells and as other topics of this electrochemistry, and we'll, after completing this, we'll start the new chapter. Okay. So stay connected with this NEET World YouTube channel. So where we'll be providing you clear and excellent content. So either you can join the batches or you can stay connected with this channel to get most best content of this NEET and JEE. So thank you for watching. Thank you.